disable SELinux! SELinux is probably not your problem, so don't disable it. Stay tuned as we talk about what it is and how it works. SELinux is short for Security Enhanced Linux, and it's one of the security features built into Red Hat distributions. Not just Red Hat Enterprise Linux or RHEL, but also Fedora and CentOS, and even other Linux distributions are starting to use it as well. What it's there to do is to limit the scope of applications, to control what their responsibilities are, and also keep them from interfering with other resources or applications running on your machine. So we're going to give you a couple of guidelines to help keep you on track for working with SELinux. 1, put things where we expect them to be, and we'll talk about why this is in just a minute. 2, if you're using weird ports, that may cause you some problems. So if you're sticking with the standard ports for your service, you're probably fine. But as you start to deviate from those standards, there's a little bit of extra you need to pay attention to. And 3, if you suspect that you're having an SELinux problem, we'll talk about a quick way that you can establish whether that's really the case or not. I think the first thing is to understand that in SELinux, there's this concept called a context. And there's an old saying, context is king, and that is 100% true in SELinux. Essentially, your processes, your applications, they all have a context setting that controls how they interact with the security policy being enforced by your SELinux subsystem. Not only do the applications have a context, but different resources on the machine, like network ports, they will have a context. Files and directories will have a context. So let's take a quick look at what this looks like, and we can see kind of how they line up and jive with each other. All right, the first thing we're going to do is we're going to take a look at processes and their contexts. And you'll notice that every application or every command that I run, I'm going to use the -Z option, that's -Z, which will show you the context settings for each of these different components. So for example, we're going to start with a ps-auxz. And that's going to show you your process status, and that Z at the end will make sure to include the context for SELinux along with all those processes. All right, now the output looks messy, but that very first field right here, this is the context with which this application is running. And there's several fields to the context, and the colon that you see in this output is a separator between each field. There's the user field, the role field, the type field, the sensitivity field, and one that you don't see reflected in this output, the category field. But the one that we really care about, if you're just getting started in SELinux, is that third field, the type field. Because it turns out our default policy only looks at this field when making decisions, when enforcing rules in the SELinux policy for the machine. And we'll talk a little bit about policy in just a second. All right, so we can look at this output here, and what I notice is that this is a kernel T type process. This one up here, that's an unconfined T type process. And so different applications will have different contexts assigned to them. All right, I mentioned that we're going to come back to the policy. One quick note on it. The default policy we use on most Red Hat distributions is called targeted policy. And we'll take a look at how you can look at what settings are there in just a few minutes. But the targeted policy gets that name because it targets specific applications. And so, for example, the web server that you have running on the machine, that will be covered under the targeted policy as one of the targeted services. You can see in this output, the kernel T, kernel is one of those targeted applications as well. Samba and CIFS file sharing, that's a targeted service. NFS is a targeted service. And there's a bunch of them in that list. But the reason I'm going into this depth is because the one that I have highlighted right now, unconfined T, that's for services that are not targeted by the policy. And so a lot of your third-party services may end up being in this unconfined type. Unconfined T is this catch-all grouping that essentially will keep them from being limited by a variety of other SELinux policy rules. So it's probably a really broadly scoped group. Okay, so we took a look at PS, and we saw our processes, and they have contexts. So let me also show you what it looks like on the file side of things. So I'm going to do an ls-Z or capital Z on some directory. I'm going to choose var www. All right, that's where we expect all of our web services content to go. And you can see that the context that goes along with the directories underneath here are things like httpd sysscript exec right there, get content t, and httpd syscontent t. So these are all content types or contexts that go with web services, or you can even see Git services in here. And what will happen is when a program of a certain context tries to interact with a file or directory of a certain context, the rules and the policy will decide whether it's allowed or not allowed to access those files and directories. So different applications will have permissions in the policy to access different types of files. All right, so we want to keep applications in their own stuff and not have them access other people's stuff or other applications' things or resources like network ports that they shouldn't have access to. And so here we're looking at the web services. So if you were a Apache web service or Nginx web service, you should have access to the web content for your website and whatnot. And you can see that the directories where we would store that stuff has the correct context that identify it as HTTP style content. It turns out that those processes also have access to etc type files, right? Like configuration files, because they need to have access to their own configuration data. But it would not allow them to access things like home directory user files. Because why would an application that's a web server be trying to access user home directories? So there's rules that control what applications have access to on the machine. All right, so that's a little bit about contexts and context being king. The first guideline that I'm going to give you to help keep you on track is put things where we expect them to be. These contexts, especially the file and directory contexts, are inherited. So if you take your web directory stuff and you put it somewhere else on the machine, it's probably not going to have this HTTPD syscontent t type assigned to it. In fact, let's just touch a file in the top level directory, the root directory, called /web, and take a look at its context with ls-z. Right, you can see that this is a etc runtime t type file. Does Apache or Nginx have permissions to access an etc runtime t type file? Maybe, but probably not. So if you put things in weird places, they may not get the right contexts. So your guideline number one, put stuff where we expect it to be. Web content goes in the web directory. Email stuff goes in the email directory. Configuration files in the etc directory. Home directory stuff in the home directories. So if you keep things where they are expected to belong, likely the context that they'll be assigned by default will be compatible with your targeted application. All right, rule number two, when you're working with network ports also have a context. And so when a process like a Apache web server tries to attach to a port to listen for incoming connections, it needs to attach to one that has the right contexts. And we could look at the available ports and their contexts with the command semanage, which allows you to manage different SELinux settings. We're going to tell it port, because we're interested in ports, -L to list the ports. All right, so it goes through and you can see the context type on the left-hand side of the output. You can see the connection type, TCP or UDP, is the second field. And then the third field is the port numbers that go along with that context. So let me just take this list and clear out and look at just the HTTP style contexts. So I'm going to do the same semanage port -L, and I'm just going to pipe that to grep, so we only show the lines that match HTTP. So I'm highlighting this line right here, HTTP port T. That's the context. And you can see that it's UDP, and there's another one, TCP. And this is the list of ports that are allowed of this type. So if you were starting up Nginx or Apache, it could attach to ports 80, 81, 443, 488, 8008, 8009, 8443, or 9000. Let's say that we wanted to start it up and attach it to port 8080, 8080. It's not in this list. That's up here in the HTTP cache port T. So caching web servers would be allowed to connect to that port number. So if you're attaching to a weird port number, a non-standard port number, that may cause problems. And what you'll see is when you start up the service, you'll get an error message about not being able to open the port. And if you look in the associated error log file for your service, it probably has a message about being refused access to that port number. And the SELinux context is probably a good place to check before you move any further. All right, so processes have context. Files and directories have context. Network ports have context. And all these things together define what an application is allowed to have access to on your machine. All right, so let's step back for just a second and talk about SELinux general settings. So I mentioned earlier that SELinux is probably installed and enforcing by default. How do you know? Well, there are a couple commands that we can use for that. One is we can take a look at a command called getenforce. Getenforce will show you the enforcing status of SELinux. And we can see on this machine, it's set to enforcing. It is enforcing the policy and the rules in the policy. The other things that you could see as output would be permissive, meaning it's checking the rules in the policy, but not enforcing them. So if somebody violates a rule, they will be given an error message, but not forbidden from doing whatever it is it's trying to do. So really it's more like logging, producing logs. The third state is disabled, and disabled means that we're not checking the policy at all for anything. That's not a state you want to be in. All right, so getenforce will be able to show you whether what your SELinux state is. The other one I really like gives you a lot more detail, and that command is SEStatus. All right, so you can see in SEStatus, the first line is what is the enforcing status? And we can see that this one is enabled. Down a little bit further, there's the current mode. It's an enforcing. And the other thing I like about this output is it gives me the policy name. I said earlier that we used by default the targeted policy, and here you can see at the output that we're using the targeted policy. All right, there are other policies that ship with Red Hat Enterprise Linux or Fedora or CentOS, but you want to use the targeted one, especially if you're new to SELinux. It is the one that we ship by default because it generally has the right rules and usually works just fine. What happens when you suspect that you're having an SELinux policy problem? One, we would like to see that there are maybe some error logs or other stuff in the logs on the machine indicating that there is some kind of mismatch. But not every application is graceful about telling you that. Realize that how SELinux works is when somebody accesses a resource and we check it against the policy and that resource is refused to them, we send back a refusal message to the application. A lot of applications will interpret that refusal as a denial. And so you'll see things like permission denied or something failed, but not any mention of SELinux per se. So maybe you're in that state and you're thinking that you may have an SELinux policy problem or an SELinux problem. What do you do? The last thing I'm going to show you is a temporary way to change your enforcement mode on your machine. So currently this machine isn't enforcing. We can see that by running getenforce. Right? You can see it's in enforcing mode. Well, if we temporarily want to disable the enforcement of the policy, we instead run setenforce. Setenforce takes a 0 or 1. Either we are enforcing or we aren't enforcing. So if we want to temporarily disable SELinux, we setenforce 0. And if we run getenforce again, you can see it's now been toggled into permissive mode. So if your problem goes away, you need to look at the SELinux subsystem, its context, how it's interacting, where it's stored. That's going to be the direction of your search. If it turns out that your problem persists, It's probably not an SELinux problem because it's in permissive mode. It's not stopping anything from occurring. So the way that you toggle it back, setenforce 1, and we can use getenforce, and we can see that we're back in enforcing mode, right? So you can temporarily disable SELinux for the purposes of troubleshooting, but generally it works pretty well these days. So it's not like back in the early 2000s where it caused problems with a lot of applications. There's no reason to disable it now. You want to keep it enabled because it gives you that extra layer of security, that extra layer of keeping applications from doing things that they shouldn't, and generally it just works. So put things in the right place, make sure you don't attach to wonky ports, or if you do, check the SELinux policy settings for ports. And the third thing is, if you think it's really an SELinux problem and you don't see anything in the logs, temporarily disable it, test it again. If it works, keep working that SELinux angle. If it's not, or it continues to fail, turn SELinux back on because it turns out that's not your problem. So those 3 guidelines will help keep you on track for using SELinux. Thanks for watching our brief introduction to SELinux. You want more? Leave us a comment. Tell us what more you want. Maybe you're having a weird SELinux problem. We monitor the comments. We'll respond. Hit us up.